Okay, so this video is going to walk you through the steps that you would take to answer a couple of different titration problems. So hopefully it will help answer any questions that you may have when you're starting to review for the test. So this is an example of the type of problem that you would see on the test. If you have 50 milliliters of 0.3 molar KOH used to titrate 75 milliliters of H2SO4, what is the molarity of H2SO4? So the key things to pay attention to here are you have the concentration and the volume of KOH. You also have the volume of H2SO4, and what you're looking for is the molarity. I will always give you the balanced equation so that you'll be able to find your molar ratio, which you'll need not in the first step, but in the second step. So first step is going to be you have to figure out how many moles of KOH were used in your titration, and we will use the molarity equation for that. So I have to look back at my problem and say, okay, I know my molarity is 0.3 molar KOH. I'm trying to figure out how many moles I have, and I know that I have 50 milliliters, and 50 milliliters, I need to convert that into liters. 1 liter is 1,000 milliliters, which means if I want to change my milliliters to liters, my decimal point needs to move 3 spaces. So I'll do 5, 0. This is my original. To convert it to liters, I have to move 3 decimal places to the left. So I have 0.050 liters. At this point, I'll just do the math. So to solve for x, I'm going to take my 0.050 liters times 0.3 molar KOH, and I get that I have 0.015 mole KOH. All right, so I have how many moles of KOH were added to the beaker of H2SO4. So that's a pretty good start. But that doesn't tell me how many moles of H2SO4 are there, which is what I'm going to need in order to calculate my molarity. So I have to then use the molar ratio between KOH and H2SO4 to figure out how many moles of H2SO4 I have. So I know that I have 0.015 mole KOH, and I'm trying to figure out how many mole H2SO4 that equals. So I need to look at my balanced equation and find my molar ratio. Now it doesn't matter that these are on the exact same side of the equation. I can still create a molar ratio by looking at the coefficients. So I have a 2 in front of my KOH, and it's understood that there's a 1 here for the H2SO4. So my molar ratio is 2 mole KOH equals 1 mole H2SO4. Once I have the molar ratio, I can do my third step, which is to use stoichiometry to calculate the number of moles. So I had 2 mole KOH equals 1 mole H2SO4. I know that I'm starting with 0.015 mole KOH. So that's going to be the start of my stoichiometry, the start of my railroad track. I then take this and use it to convert from mole KOH to mole H2SO4. So I have 2 mole KOH on the bottom, 1 mole H2SO4 on top. This way, mole KOH divides out. So I would take my 0.015 and divide that by 2, which equals 0.0075 mole H2SO4. So this is how many moles of H2SO4 I have. So I can finally do my last step to solve this, to answer this question about the molarity of H2SO4 by, once again, using the molarity equation. Molarity equals moles over liters. Okay. I know that I have 0.0075 moles of H2SO4. And if I go back to my original equation, I know that I have 75 milliliters. So again, 75, if I wanted to change my milliliters to liters, my decimal place moves 3 places to the left. So I have 0.075 liter, and that's going to equal my molarity H2SO4. So 0.0075 divided by 0.075. So my molarity is 0.1 molar H2SO4. That is my final answer. So again, if we walk through these steps one last time, the first thing I did was to calculate how many moles of KOH I had. And I knew to start with that because I had both the volume and the concentration of that substance. Then I took that balanced equation to find the molar ratio. And I need the molar ratio so I know how many KOHs for every H2SO4. In this case, it's 2. Using the molar ratio, I took the number of moles KOH in order to use stoichiometry to find the number of moles H2SO4, and then finally took the number of moles H2SO4 divided by the given volume in the problem, in the question, to calculate my final molarity of H2SO4. So that's one problem that you will, one type of problem you will see on the test. Another is very similar, but a little bit different. The steps are still going to be the same, but you're not necessarily always going to be solving for molarity. in this case, I have the question, if 32 milliliters of 0.76 molar H2SO4 was titrated with 0.092 molar KOH, how many milliliters of KOH were used? So for this question, I'm actually trying to figure out how many milliliters of KOH were used in the titration. Now again, I'm going to start off with the exact same process. I need to, in order to go from information about H2SO4 to solve for information about KOH, I need to figure out how many moles of these substances are involved. So to start off, I need to calculate how many moles of H2SO4 that were in the beaker. I know I need to start with H2SO4 because that's the one that has the given volume and concentration. Actually, it's a little light. Let me get a darker color. Okay. So my molarity is 0.76 H2SO4 equals, I'm trying to solve for moles, and I know that I have 32 milliliters, so again, moving the decimal place 3 places, that becomes 0.032 liters. To do the math for this, I'm going to multiply 0.032 liters times 0.76 molar H2SO4. And that gives me 0.024 moles H2SO4. So I now know how many moles of H2SO4 were titrated. But I'm actually looking for information about KOH. So I need to be able to convert between H2SO4 and KOH. So again, I need to look at my molar ratio. It's the same as the last problem. For every 2 moles of KOH, we need 1 mole of H2SO4. And again, that was found by looking at the coefficients in the balanced equation. Once I have that molar ratio, I can calculate using stoichiometry how many moles of KOH. So if I go back to my first step, I had 0.024 moles H2SO4, so that is my starting point. 0.024 mole H2SO4. And I have my molar ratio of 2 moles KOH equals 1 mole H2SO4. So I put 1 mole H2SO4 on the bottom, 2 mole KOH on top. My mole H2SO4 divides out. So take that 0.024 times 2, and I have 0.049 mole KOH. It was 0.0486, so I round up to 0.049 so that I have 2 non-zero digits. All right, almost there. I have the number of moles. So my last thing is to go back to my molarity equation. Molarity equals moles over liters. And I'm going to plug in the information that I have. Now you can do this a couple of ways, but I'm going to walk through the whole process as one problem. So I start off, I know that I have 0.049 moles KOH. Liters is what I'm trying to solve for, and I know that my molarity is 0.92. Okay. Now if I want to solve for x, what I need to do is multiply both sides by x, so that x comes out of the denominator, and this will become 0.92 KOH times x equals 0.049 mole KOH. Now it's a little bit easier to solve for x because it's no longer in the denominator. X equals 0.049 divided by 0.92. So if I do that math, 0.049 divided by 0.92, I get that I have added 0.053 liters. And again, to convert from liter, I'm going to move my decimal point 3 places, but this time to the right. 1, 2, 3. So 0.03053 liters equals 53 milliliters. This is my final answer. It takes 53 milliliters of KOH to titrate, of 0.92 molar KOH to titrate 32 milliliters of 0.76 H2so4. So hopefully going through each one of these steps will help a little bit with the studying process. Again, they're always the same steps, no matter what you're solving for. You always start off by figuring out number of moles, then you find your molar ratio so that you can convert from moles of one compound to moles of the other compound, and then finally go back to your molarity equation to solve for the final answer.